Hey, welcome back. So, in this particular lecture, we'll be discussing the basic calculus that will be required to understand physics. Okay. So, let's start by discussing some of the things that you have already learned in class 9, 10, which is dealing with constant quantities, right? So, let me give you an example. So, the most easy example I can give you is this. Imagine you have a block B of some mass, and I tell you that this is traveling at 20 meter per second at a constant speed, right? So from this statement you understand that when this block is going to move here, this velocity will still be 20 meter per second only, right? And when it reaches here also, its velocity is going to be 20 meter per second only. These kind of analysis is going to be very easy for you because you have a uniform velocity in this case. And if I suddenly ask you that after let's say 10 seconds, what is the distance that this guy traveled, this block traveled, you can simply use the formula of speed is equal to distance by time, right? Plug in the values. You can say the speed was what, simply 20 meter per second. Distance we have to find, and the time is 10 seconds. So when you cross multiply, you get that the distance traveled was simply 200 meters, right? Very simple. But imagine situations where the velocity is not constant. Imagine you have a situation where the velocity is not constant. 20, instead of 20 meter per second, when he reaches this location, this becomes 40. When it reaches this location, this becomes 60. Then you cannot simply apply these kind of formulas, right? You have to go into a different sort of analysis, and that is when we require calculus, right? So before actually doing the calculus part, you have to understand why we have to why we need calculus, and what is the need for us to represent, you know, any kind of physical quantity like force, velocity, acceleration, any kind of thing in a mathematical expression. Okay. And that should be evident from the fact, let me give you a very easy example, another example. Imagine, okay, so imagine you have a block and you know the distance. Okay, so this is, let's say, this is located at x equal to 0. So this is the distance from where it is located. This is x equal to 1 meter. So when the block has traveled from 0 to 1, it has traveled 1 meter. Then it goes to x equals to 2 meter, right? And let's say this reaches x equal to 3 meters. Now imagine a velocity like this. Initially, when the block is at 0, the velocity is 0. When the block is located at x equals to 1, the velocity becomes 1 meter per second. When the velocity is when the block reaches 2 meter, the velocity becomes 4 meter per second. And when it reaches 3 meters, the velocity becomes 9 meter per second. Okay. So guys, can you tell me a relationship between velocity and displacement? Pause the video and give it a try. Okay. And then let's talk about it. Okay. The relationship between velocity and displacement at this location is v equals to x squared. Okay. So these kind of let me move myself downward and then let's talk about it. Okay. So these kind of scenarios where you have variable physical quantities, the word is variable. I'm using variable. Variable means it's changing. It's changing with respect to something. Here this is a variable with respect to displacement. Sometimes it may be also a variable with respect to time, right? So when you say variable, you should also add with respect to what? With respect to what is your physical quantity varying? Okay. So here I want you to understand why we have to express v in terms of x. Otherwise, if you can't express this in terms of x, to any person you are explaining, you have to give them a huge table. You have to tell them, sir, see, you have x in one column and v in the other column, and you will make table like this. You will say at 0 velocity is 0, x at 1 it is 1, this is 2, this is 4, this is 3, this is 9. You have to give a very big table to give the entire analysis, right? But if you give him just a simple equation of v equal to x squared, this will represent this entire table in a single equation. That is why we need functions. We call this what? Functions. Here, velocity is a function of x and I am representing this as x squared. So anywhere that you see that in physics, as soon as you start doing kinematics, the first chapter in physics, you'll realize that no longer we are dealing with only uniform quantities. Obviously we'll be dealing with uniform quantities also, but we'll also be dealing with variable quantities. So when we are dealing with variable quantities, it is very, very important for us to express these variable quantities as a function of displacement or as a function of time. Most of the cases it will be a function of time, but you have to understand it's not always a function of time. Sometimes it can be a function of other physical quantities also, like displacement. It can be a function of temperature, it can be a function of, I don't know, other physical quantities like light intensity. So it's like it can get very, very advanced, but the basic understanding is this only, that sometimes your quantities are not constant. It can change with respect to something. When it is changing with respect to something, you should be able to express that quantity in terms of the quantity with respect to which it is changing. Okay, so that is the basic idea here. Let's move on to the next part. Okay, so okay, one more statement here. These functions have a dependent variable and independent variable. What does this mean? This means that in this particular scenario, in the example that we took, x is the what? It's the independent variable, because x is increasing 0, 1, 2, 3, and based on this x, velocity is changing. So x is the independent variable, and v is what? The dependent variable. Why is it dependent? It is dependent on x. The dependent variable is dependent on independent variable. Okay, so whatever I'm saying, just pause and repeat, you'll understand. It has similar words, but it's a very simple statement. This is the dependent variable, this is the independent variable. V is depending on x in this scenario. Okay, let's move forward. Okay, okay. Let's take a very simple example. Okay, let me introduce differential calculus to you. Differential calculus. Okay. Let's take an example for displacement, which is expressed as a function of time. Okay, so let me 3t square plus 2. Let me write it down in my blackboard. That way it becomes slightly more clear. So we have a displacement as t as 3t square plus 2. What does this mean? First of all, when you are given a function, without going into what the question is asking, first analyze what the function stands for. Try to understand what this equation means to you. Okay, so what this means is that you have some imaginary body, and you are also measuring the time. Okay, so as soon as you start observing what is the position of this body, the position of this body is 2 meters. How did I get this? I put t equals to 0. At t is equal to 0, st is 3 times 0 square plus 2. What did I do? I just plugged in 0 in place of t. This gave me the answer 2 meters. So that means when I started observing, the body was located at 2 meters. 2 meters from where? From the origin, from the reference point, from where we are measuring the distance. Maybe there is a wall, maybe there is a signpost, I don't know. But at t is equal to 0, I know that the position, the body is located 2 meters from something. Okay. What about t is equal to 1 second? At t is equal to 1 second, it will be 3 times 1 square plus 2. This means 5 meters. This means 5 meters. I'm giving you 2 seconds to absorb this. What am I doing? I'm just plugging in the value of t in this given equation. So our equation was 3t square plus 2. I plugged in 1 and I got 5 meters. Similarly, at t is equal to 2 seconds, t is equal to 2 seconds, the body is 3 into 2 square plus 2, which is 3 4s are 12 plus 2, 14 meters. Okay. So that means the body was located at t is equal to 1 second, the body was located at 5 meters. And at t is equal to 2 seconds, the body is located at 40 meters. Okay. So I hope you understood what this equation stood for. And I can keep on going for every other second, right? This is the good thing about an equation is you don't have to limit yourself to a few numbers, right? You can put this one equation is giving you the entire motion up to infinity time, right? No matter what time you put, you can get the value of the displacement at that time. Okay. Let's move on. Now, in this experiment, the next thing I want us to do is I want to find out the velocity. Okay. To find out the velocity, I know the displacements, right? So from t, let's say I want to find out the velocity between t. I want to find out the velocity. First of all, if somebody asks you what is the velocity, what will you say? First of all, you have to define what time interval I want the velocity of, right? T is equal to I want it at t is equal to 0, or I want it at t is equal to 1, or I want it at t is equal to 2. If somebody asks you what is the velocity of this body, you cannot tell, because you see why you cannot tell is because if you look at this in the first second, 0 to 1 second, what is the displacement? It is 3 meters. 5 meter minus 2 meter is 3 meter. The body has traveled 3 meters in 1 second, right? But in the other second, t is equal to 1 to t is equal to 2, this body has traveled how much? It has traveled 14 minus 5, which is 9 meters. 9 meters in 1 second. So what will you tell? Is it 3 meter per second or 9 meter per second? So that is the main question here, right? So here I have made a table like this. From 0 to 1 second, the change in displacement is 3 meters and the average velocity is 3 meter per second, right? From 1 to 2, this is 9 meter per second, and from 2 to 3, 2 second to 3 second, it is 15 meter per second, right? So simply knowing कि velocity is change in displacement upon time will not help us in variable displacement, because we cannot apply this. If this was a simple question like the one that we did earlier in the beginning of this lecture, if I gave you okay, this is traveling, the displacement is changing 1 meter every second, then you will simply say the velocity is 1 meter per second, right? But situations like this, when displacement is not constant, it is changing with respect to time, finding out velocity becomes difficult. It is at that time when we have to reduce the interval of time to find out the accurate result of the velocity. Let me repeat that statement. That statement is very, very important. This time slower. If I want to find out the accurate velocity at any point in time, I need to reduce the amount of time interval, because the closer, the smaller the time interval is, the more accurate it will be in terms of velocity at that particular time. Okay, so the next thing I can do is, instead of taking 1 second interval, I can reduce it to 0.5 seconds, and then be like, oh, at 0 second and at 0.5 second you find out the displacement, and then you find out the change in displacement, and then you find out the velocity, 1.5 meter per second, 4.5 meter per second, right? So do you see the pattern here? I can reduce, but somebody will say I can reduce the intervals further. I can go 0 to 0.25 also. I can go from 0.001 to 0.002. That will be much more accurate, right? So this is where we need differential calculus. Differential calculus will help us to find out the velocity at very, very small intervals. That is the use of differential calculus. What it does is, like, if you try to imagine in terms of a curve, okay, virtually, like, with a graph, if you want to represent this, what this means is, you can see this animation here. If you want to decrease the time interval, this is written x, but imagine this is time interval. So if you want to reduce the time interval to very, 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 very small, essentially you are trying to find out the tangent to that particular curve. This will become more clear when you study math and coordinate geometry in special. But for now, you have to understand that if you want to reduce the time interval to very, very small so that your answer becomes 100% accurate, you have to take your interval to be infinitely small, infinitesimally. There is a word for that, right? Infinite, you know, infinite, right? Infinite means very, very big, very, very big, right? Infinitesimally small means very, 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 very small, very, very, very small. Just like infinity means very, 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 very big, infinitesimally small means very, 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 very small. So you understood the pattern. If I want to find out an accurate velocity for a variable displacement, let me repeat again. If I want to find out the accurate velocity of a variable displacement, we need to make these intervals 1 second and 1 second will not do, because those are giving, you see, different answer they are giving, right? So we need to make it small, small, small to the point it becomes very small so that your answer is 100% accurate. What is the way to do it? By using something called the differential calculus. Something called the differential calculus. Now that you understand why we need differential calculus, it is time that we learn how to do differential calculus. Okay. So first of all, you have to understand, just like do you remember the arithmetic operators plus, minus, multiplication, divide? What does it, what is this, what are these? These are operators that we use to perform specific actions on numbers, right? For example, 2 plus 2, this is the function, this is the operator that is applied on these two numbers, 2 plus 3, let's say, and this gives us 5. So this is a certain rule that is true for plus. This will not be true for minus. For minus 2 minus 3 will become minus 1. So you understand that any kind of mathematical operator will have certain rules. So I am going to start by discussing the rules of differentiation. So you have to be, since you are in 11th standard, do you remember how much time it took for you to understand plus, minus, multiplication, divide? I think it's almost, people in children almost spend 2-3 years understanding plus, minus, divide and multiplication. But in as soon as you come to 11th class, two mathematical two mathematical operators will be taught to you in a single year. In a single year they will teach you differentiation and integration. And in actuality, right now, I will teach you in 5 minutes, 5-10 minutes, I will teach you what is one operator. So you have to be very, very open-minded, okay? You have to learn the rules, and then you also have to learn how to apply it in a single class, okay? So you have to be very open-minded here. Take your time, okay? Any doubt that you have, also you have to understand, since this is a basic mathematical course, we cannot go too much into why, right? We'll be going too much into how, right? So how do we do the differentiation is gonna be, should be the focus of your attention, okay? So let's first discuss the few what can I say, the rules, okay? So okay, so the first simplest rule is going to be this. So this is the symbol for differentiation, okay? D by dx. So just like plus is the symbol, let me draw it properly, d by dx. And when you apply d by dx to any sort of function, it will give you an output. For example, if you have some function fx, so how do you apply d by dx to this? You just write like this, dfx by dx. This means you are differentiating fx with respect to x. So whenever you write x in the bottom, it just means you are differentiating with respect to. I'm going to write this as well. Differentiation with respect to x. Okay. So this is the operator. Let's do the first d by dx of x raised to power n. The formula for this is n times x raised to power n minus 1. What does this mean? What you might be wondering, sir, what is this that you wrote? Okay, let me show this to you with an example. If you are differentiating d by dx of x raised to power 5, 5 is just an example, this operation will give you 5 times x raised to power 4. Did you understand what I just did? If you have any function, any x raised to power n, and I differentiate this with respect to x only, then n will come down and the exponent will be reduced by 1. So that's why when I differentiated x raised to power 5, this became 5 times x raised to power 4. So can you tell me what will happen if I differentiate x raised to power, let's say 100? Pause the video and give me an answer. And then when I give the answer, check whether you are able to correctly do it or not. The answer will be 100 times x raised to power 99, right? So this is pretty easy. Let's do a negative number as well. Let's say differentiation of x raised to power minus 10, right? Do it and then let me know if you're able to correctly do. This would be minus 10 x raised to power minus 11. Okay, so we're doing minus 1, no matter whether it's a positive number or a negative number. So if there is a negative number, minus 10 minus 1 will become minus 11. Okay, so this is how this is the first formula for differentiation. Whenever you have to differentiate x raised to power something, then you have to simply do this. Okay, the next formula is something like this: d by dx of sine x. Right, so if you have a variable quantity in terms of sine x, okay, x is variable, and you have to differentiate sine x with respect to x, then you'll get what? Cos x. Okay, something that you have to remember. Again, these are formulas. You no need to understand. Don't ask the question why in this, because the why will come when you study math. They will teach you why the differentiation of sine x is cos x. But for physics right now, we need to know that differentiation of sine x is cos x. Up to that knowledge is enough. Okay, to just deal with physics right now. Later on, when math teacher is teaching differentiation of sine x is equal to cos x, don't just let him tell you that sin x is cos x. Ask him why. Why is sin x, differentiation of sin x is cos x? Okay. Okay. The next formula is differentiation of cos x. Differentiation of cos x this time. Like, so you have cos x, x is the variable, and you have to differentiate cos x with respect to x only. This will give you minus sin x. Nice. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Okay, let's give you some more formulas. Okay, we can just go into the slide and then let me show you. Yeah, so you can note down all this. The first one is constant. So if you're differentiating excuse me, if you're differentiating any function of x, then you are getting things like x raised to power n minus 1. You are differentiating log x, then you get 1 by x. If you're getting sin x, differentiating sin x, you get cos x. But if you happen to differentiate a constant number like 5, 6, 7, 8, 9, 10, not a variable, an actual number like 10, minus 10, pi is also a number, right? So if you're differentiating a constant real number, the differentiation comes out to be 0. That is the first formula that is written here. Okay, after that, the others one you can pretty much understand. Differentiation of tan x is x square x. These already I showed you. Log x, if you don't know what log is, ask one of your teachers when you come for offline classes, right? You can ask what is log. They will pretty much explain to you what is log. And differentiation of log x is 1 by x, right? So this is how you perform differentiation. Let me give you a few examples also, but let's see what the next topic is, which is this. There are some arithmetic issues also. You might not always face the, okay, this differentiate x square. They might ask you differentiate x cube plus x square. How will you differentiate this? You can differentiate this by using this first formula here. If you want to differentiate a plus minus b, plus or minus, like this is plus minus means you can either have a plus b or a minus b. Then what you can do, you can differentiate the first function and then differentiate the second function and then add them together. So how can I solve this differentiation? If I want to differentiate x cube plus x square, this entire thing, I can differentiate x cube first and then differentiate x square later on and then add them together, right? So what is the differentiation of x cube? It will be 3 times x square plus 2 times x raised to power 1. Tell me if you got the same answer. Okay, now let's do the next one. D by dx of sin x plus cos x. How will you do this differentiation? Pause the video, do it yourself, and then let's check the answer. Okay, so this will be differentiation of sin x followed by differentiation of cos x, and then we add them together. So this will become what? What is the differentiation of sin x? It is cos x. And what is the differentiation of cos x? It's minus sin x. So this is the answer. So if you are differentiating sin x plus cos x with respect to x, you get cos x minus sin x. Okay, so leave in comments if you are able to solve it. Okay, let's move on to the next one. What if two things are multiplied? For example, if you have to find out the differentiation of, let's say, sin x multiplied by cos x, how would you do that? The answer is simple. Okay, the formula for this is, first you leave sin as it is, sin x as it is, and then multiply the differentiation of cos x, and then you leave cos x as it is and then differentiate sin x. And if you see it in terms of a and b, you can see it in this formula sheet. If you want to differentiate a multiplication of a and b, first you leave a as it is and then differentiation of b, plus b as it is, differentiation of a, right? So this is the formula that I just did. So sin x, differentiation of cos x is minus sin x, and then cos x as it is multiplied by differentiation of sin x is cos x. So this will simplify to cos squared x minus sin squared x. So differentiation of sin x multiplied by cos x with respect to x is cos square x minus sin square x. One more question for practice. D by dx of, let me give you, log x multiplied by x raised to power 5. Let's say this is the problem we are dealing with. Okay, so how will I do it? Simple. So for you, pause the video, do it yourself, and let's check the answer. Let me know in the comments if you are able to do it correctly. Okay, so d by dx log x multiplied by x raised to power 5. So differentiation, so what I'll do is leave log x as it is followed by the differentiation of x raised to power 5 plus x raised to power 5 as it is, differentiation of log x, right? So this is the formula. So log x is as it is. What is the differentiation of x raised to power 5? This is simply 5 times x raised to power 4, right? Bring 5 down and then 5 minus 4 on top. Okay, and then plus x raised to power 5 as it is. Differentiation of log x is 1 by x. So if I simplify this, this becomes x raised to power 4. Okay, so this becomes 5 times x raised to power 4 log x plus x raised to power 4. So this is how you do the product rule. Okay, we call that the product rule. The one on top, these ones, a plus b, these are the addition rules of differentiation. This is the product rule of differentiation. There is also a quotient rule of differentiation, which we are not going to discuss right now because it's not essential for the use of physics. Okay, Okay, the next thing I want to discuss is the chain rule. So this completes the entire differentiation. So if you know all of this, you can pretty much deal with the initial phase of physics. Any differentiation that is required for physics only is discussed here. So if you know the basic formulas, if you know the addition rule, the product rule, and the chain rule, then you are pretty much set for differential calculus in physics. Okay, so let's discuss the chain rule. Okay, so what is chain rule? Chain rule essentially means, like, for example, you want to differentiate something like this: sine x to power 5. What is this? This is a composite function, right? It is like, you know the differentiation for x raised to power 5. You also know the differentiation for sine of x, but you don't know what is the differentiation for sine x raised to power 5. Here you have to apply chain rule. Chain rule because it's a composite of two functions matched together, right? Another example would be something like this: log of sine x. So you know that, you know what is the differentiation of log x, you know what is the differentiation of sin x, but you don't know what is the differentiation of log of sin x. Okay, so for in these scenarios, when you have function on top of another function, you will need to use what? The chain rule. Okay, so what does, I'll just teach you how to apply the chain rule. It's very, very simple. Let me show you how. So what you have to do is, initially, for the outer function, what is outer function? Outer function in this case is sine. How do I know this? Because if I, for example, instead of differentiating, if I have to solve this, for example, I gave you x is equal to 30 degree. What will you do? You'll plug the value 30 degree inside. You will do, let's say, sine 30 degree raised to power 5. So what will you do first? Will you do sine 30 degree and raise it 5 times? Or would you first raise it 5 times and then do sine? The answer is, you'll raise it 5 times. I hope you know the Bodmas rule, right? Here the x raised to power 5, the power 5 is actually attached to the x, not the sine itself. You have to differentiate between this and sine x raised to power 5. These are two different functions. Okay, first of all, understand the difference between sine x raised to power 5 and sine x raised to power 5. Here, if you are given x is equal to 30 degree, first in this function you will first do what? You'll raise 30 degree 5 times. 30 into 30 into 30 into 30. Okay, and once you get that answer, then you are going to put sine of that particular angle. But in this one, sine x raised to power 5, this you will do sine 30 first. Sine 30 you will do and find out, okay, sine 30 is half, and then half raised to power 5. So these are two different functions. In this, x raised to power 5 is the inner function, and sine x is the outer function. It's pretty common sense. Okay, pretty common sense. In this one, sine x is the inner function, and x raised to power 5 is the outer function. Okay, so you have to identify what the outer function is. So now coming back to differentiation, if I have to differentiate sine x raised to power 5, what will I do? I'll simply do the differentiation of sine x, considering that this entire thing inside the inner function is a huge x. Okay, it's just x only. Okay, so I'm gonna consider this, I'm gonna use a different color here. I'm gonna think like this is a huge x. Okay, so what is the differentiation of sine x? It is simply cos of x. And what is x for me? X raised to power 5. Did you understand the first step of this? The first step is that the inner function, you think of this as a huge x. It's a huge x. Okay, sine x. Differentiation of sine x is only you are doing. So like that, treat it like that and do the first differentiation. You say ki differentiation of sine x is cos x. So the first part of this would be cos x raised to power 5. But then you have to compensate for that assumption you made, right? You'll have to differentiate x raised to power 5 again with respect to x. Do you understand what I just did? Did you understand what I just did? Okay, so let me explain again. if you're ever in a situation in which you have to differentiate a function which is a composite of two functions, in that case consider the inner function to be an entire x and then differentiate it. But after you differentiate it, you have to compensate for that assumption by differentiating the interior function again once more. Okay, so I'll do it multiple times. 2 3 examples I will give. I think you will understand once you see all the examples. Okay, so differentiation of sine x raised to power 5 will be cos x raised to power 5 multiplied by differentiation of x raised to power 5. So this will become cos x raised to power 5 and differentiation of x raised to power 5 is 5 times x raised to power 4. Okay, let's do the other one. Differentiation of log of sine x. So what is the outer function here? Log x. Log x is the outer function here. Okay, so what will I do? I'll just consider this entire sine x as a huge x. Okay, and what is this what is the differentiation of log x? Differentiation of log x is d by dx of log x is what? 1 by x, right? But for me x is sine x, so when I differentiate log sine x, I'll get what? 1 by huge x, which is sine x, right? But again I have to compensate because sine x is not x, it's not a huge x, it's actually sine x only. So I have to differentiate sine x again with respect to x. So this will become what? Sine x, differentiation of sine x is cos x, so cos x upon sine x. So this becomes what? Cos x. Nice. Okay, let's move on. One more example I'll give. Okay, d by dx of sine of log of x raised to power 5. Okay, this is slightly more complicated. This is a amalgamation of three different functions. It is one is x raised to power 5, another is log x, the last one is sine x. So you have, how do you read this? Sine of log of x raised to power 5. So three functions. How do you do this? Simple. The same agenda that we used before. We are gonna consider everything inside sine to be a huge x. Okay, so what will happen when you differentiate sine x? What do you get? Cos x. So cos of huge x. What is huge x? It will be log of x raised to power 5. But we have to do what? We have to compensate. We have to compensate by saying that we have to take the differentiation of log x raised to power 5. Now again, while doing differentiation of this, I have to use chain rule again. So this is an example where I'm using chain rule 2 times in a single question. So this one will stay here only, cos of log of x raised to power 5, right? What is how will I do this? I'll consider x raised to power 5 as a huge x again. Okay, and then differentiate log x is 1 upon x raised to power 5, but compensate again by doing d by dx of x raised to power 5. So we're now this one no need to use chain rule, this one you can directly do. Okay, so from here you'll get the answer, cos of log x raised to power 5 1 upon x raised to power 5, and the differentiation of this would be 5 times x raised to power 4. So if I simplify this, this will become 5 times cos of log of x raised to power 5 divided by x. Why x? Because x raised to power 4 cancelled with x raised to power 5 and only x remains. Okay, so this is the, I think this is the most complicated thing that you will face in physics. Other than this, I don't think this is the hardest. Like if you are able to understand this, I don't think you need to worry about anything in physics. Anything in physics, even in JEE mains and advanced, will be lesser than this. Okay, any kind of differentiation that we deal with this in physics will be lesser than this complicated question. Okay, so pause the video, rewatch it if you are confused about this, but you have to understand this part. Okay, so let me know in the comments if you have any more doubts. I'll try to clear it with a subsequent video. Okay, so this is completed. Let's move on to the next thing. Okay, the maximum and the minimum part. Okay. So I am hoping that by now you are comfortable uh, on the on the formulas of differentiation. If you are not, then I would suggest you pause the video for a bit, practice a few more questions. You can take some questions from internet as well. Just search for differentiation problem, easy differentiation problem. You can also I'll also upload a related assignment with this video where you can search for differentiation questions and do them. Solutions will be attached with the assignment. Okay, so but before going forward, you should be comfortable in doing differentiation. So write down the formula, memorize the formula, and do a few questions, and only then you go continue with the video, because the next part is application of differentiation. But if you're not comfortable in doing differentiation, then you won't be able to understand what I'm teaching, because uh, for applying something you should be comfortable and you should be able to understand that topic. Only then you can apply the topic to understand something else, right? So at this point my suggestion would be is for you to get comfortable by learning all the formulas, and then doing some questions from the assignment or from the internet or any book that you have on basic math, right? Just look for the questions and do them. Okay. Okay.